Yo, yo, it's time to discover the flow. Shout out to the bros. You know, I like to welcome everybody to discover the flow. No matter how you discover the show or discover the bros, now you about to see how far we can go, because it's time for discover the flow. Yeah, cowabunga do. You know live is how we come to you. Turn the levels up when you hear the boys coming through. The Pod Squad giving you just what you need, hitting you with a new special guest every week. Don't you dare hit skip, man, it's Tristan and Kip. DTF Pod about to take you on a trip. Mega Ran bring the heat, yeah. But be clear, I wasn't even supposed to be here. Welcome to Discover the Flow. No matter how you discovered the show or discovered the bros, now you about to see how far we can go, because it's time for Discover the Flow. Let's start the show.
Hello. Appropriately dressed for the weekend, I see.
Yeah, we're expecting freezing rain.
You know,
I don't just mean the comfy attire. I mean the Captain America shirt, since it comes out.
I didn't even know the movie was coming out until I saw people on TikTok saying, "Oh, I saw the movie." And it wasn't very good.
Yeah, I got to get this out of the way really quick. You know, Tristan usually books all the guests and does all the conversations with the guests. When he told me Dr. Phil, I apparently didn't hear the whole thing, so
He doesn't.
I'm much happier to know that it's you and not the other Dr. Phil.
Yeah, it's.
I really don't need somebody tearing apart my life.
Yeah, well. Also, I'm not a quack.
There's that too. I mean,
yes.
Being named Phil and having a PhD has caused me some amount of grief in my life because of that guy. Not a big fan of his.
Yeah, me neither. So you're in good company. I mean,
Yeah, you're safe here. You're definitely safe here.
This is definitely a safe space.
So where about in the country are you at?
I'm in Central Virginia.
Oh, okay. Right on.
Like
We're
right in the middle of
we're
the
out in the
state.
Chicagoland area, just outside of Chicago in Naperville.
I kind of know where that is. I went to the
Yeah.
University of Chicago for a year.
Oh,
Okay.
what'd you study there?
Nothing, which is why I dropped out after a year. I mean, we can talk about that if you want.
You
I'm
just
happy
kind of
to.
hung out there.
Yeah, played poker, slept in late. Yeah, it was a disaster.
I've heard that University of Chicago is good for that. You know, playing poker and doing
That's
nothing.
where fun goes to die.
Is that where you initially became the bad astronomer? Or
No, it was many years after that, actually.
so where did that come from?
Are we on? I mean, is this?
Oh
it?
yeah, no, we're
yeah,
just
we're
going
on.
straight into it.
I
We're
see.
going straight
We-
into it.
Figured this
we
was
ju-
like a cold open. All right.
Yeah, we just get going. It's a,
So we
it's
got
a
to cue the music.
conversation.
All right.
You know,
Um,
there's no fancy intro. Just let's talk. Let's hang out. You know.
We like acting like, you know, well, not acting, but we like just making new friends and talking to people and getting wonderful insights on life and things like that. So that's kind of where we're at.
And then you called me. So wow. All right. Good work, guys.
I'm
Let's see.
not. Listen, the way I'm going to say this, it's going to sound like you're boring when you're not. But many a night I have fallen asleep to how the universe works and shows like that.
Oh, I'm
you're
fascinated.
there
by the
in my
universe.
brain.
I get that a lot. Like I fall asleep listening to you, and I'm like, thanks.
That's not as much of a compliment as you guys think it is.
I mean,
We
I
need
get
to
it,
find a
you
better
know.
way to word that. Yeah.
I guess I get it. I don't see how. I mean, the show itself, how the universe works, is a really good show. I wish we were still making it, but I think the 10th season was the last one. But it's not comforting necessarily. I mean, we do talk about Saturn and stuff like that, but a lot of the episodes are like how black holes are going to destroy everything and a nearby exploding star and all that kind of stuff. Because that's sexy that you need to
Eventually
have
we're going to collide with the Andromeda galaxy and we'll all be dead.
Yeah, well, long before then anyway. That's
Well,
not for
hopefully.
4.5 billion years. So
I really hope I don't live long enough to see that.
Be on
just be a head in a jar.
my 8th facelift by then.
See, I don't know about falling asleep to that. And I did a web series called Crash Course Astronomy, and this is a 46-part introduction to astronomy. I did this with Hank Green and the crew at Complexly. I mean, if you're familiar with Hank Green and SciShow and all the great stuff they do, and the Crash Course series, there's a ton of them now, and they're fantastic for people who are interested in learning about a topic, and they're really helpful to especially students who are taking a course in high school or college or whatever about the topic. And so I did Crash Course Astronomy, which was a lot of fun, really hard work. But it's 10 minutes, 11, 12 minutes per episode. And it's for kids these days on YouTube. So it's like this, and it's edited so all the spaces are gone. So it's just me talking continuously about astronomy for 20 minutes. And I get people saying, yeah, I fall asleep listening to that. I'm like, how can you? It's somebody just machine gunning information into your ear for 12 minutes. There's no way you can sleep to that.
It's one thing when you have Morgan Freeman, narrating everything that's going on around in the picture.
Oh yeah, you're about 10 minutes in when he's doing it before you're out.
Better get astronomy or start dying. I can't.
But you figured out a way to do like astronomy for the people with short attention spans, and they're still like, "That's a bit."
Yeah, exactly.
So
you're welcome, everybody, for curing your insomnia.
So the bad astronomer nickname, where did that come
from? We were talking about that. My whole life when I was a kid, let me rephrase that seems like an oxymoron. For a long time when I was younger, I was super into supernatural stuff, like not so much ghosts and magic, but UFOs and telepathy, the kind of science fiction staples of supernatural stuff as opposed to the fantasy stuff. And I was really into it. I read books and all that kind of stuff. And then it happened gradually over the course of a couple of years where I just kind of went, oh, this is all crap. None of this works. There's no evidence for it. And it's just anecdotes. It's just somebody saying, I thought about this thing and then it happened. And it's like, yeah, but you think about a lot of things that don't happen. You need to take that into account too. Your statistics are very low. And when I started to write, basically when the internet was just getting popular, and I mean, long before the web, mind you, this is just the internet, just computers connected, and you could send text messages and stuff. I started writing about debunking misconceptions in science, not necessarily UFOs, although they and that kind of thing, but part of that, astrology and bigger topics, but also very specific things. Like in the late 90s, there's this thing going around. It's been around for about 50 years. That you can stand an egg on end on the first day of spring, on the vernal equinox, which is in March 20th or so. And you may not have even heard of it. I don't know if your listeners have even heard of this urban legend.
I've heard of that one and the broom. Yeah. There's the one with the broom is a different
thing.
Yeah, the broom came out later, which cracked me up because standing a broom up is actually really hard. Standing eggs up is easy. You just need a little practice. And I heard this legend that you can only do this on the vernal equinox. And I was like, well, that's ridiculous. If you can stand an egg up on end, you can do it any day of the year. The vernal equinox isn't a thing. When somebody describes this legend and they say, well, the Earth's gravity aligns with the sun, it's like, no, it doesn't. There's just, that happens. The Earth and the sun are on a line. There's always some point on the Earth in between the Earth and the sun. People misunderstand what the vernal equinox is. They don't necessarily understand gravity. And so I wrote about this in 1993, something like that. So holy God, over 30 years ago. Okay. And I took pictures of myself standing eggs on end and saying, look, it's July and I'm doing this. And that rumor was really popular. It turns out it began in a Life magazine. This is an old magazine that doesn't exist anymore, but this was a popular magazine 80, 90 years ago. And there's a 1940s issue where somebody wrote about this. They went to China and they saw a ritual of people standing eggs on end on what they called the first day of spring. Now, there are different ways of thinking of the first day of spring, and in China, they celebrate it 6 weeks before the vernal equinox. So it's actually in February. And it's a fertility rite. It's kind of, it's an egg, right? It's a fertility symbol. And it's kind of like the maypole and these other fertility things. And they would stand an egg up on end for good luck or whatever. And they wrote up a little article about this and put it in Life magazine. And it somehow morphed into this idea that you can stand an egg on end only at the exact moment of the vernal equinox. And so I would I wrote about it. It became popular. I talked about it on TV. I started giving talks about it. It was ridiculous. You don't hear about that rumor or that legend much anymore, and I take full credit for that. I debunked the hell out of that thing.
You take it down.
But yeah, but it kind of started my career because it was like the first popular thing I did. And then I started writing about people who think the moon landings are faked. And that took off because I was writing about it for my book. I had just been putting together my first book. And then Fox put on a TV show called Conspiracy Theory. Did we land on the moon? And, the answer is yes. And that would make a very short conspiracy TV show. But anyway, that was hugely popular. I debunked it. It was my first sort of viral thing I did. And so the whole point here, like 10 minutes ago when you asked this question, is that I was debunking bad astronomy. And I called my website Bad Astronomy. My first book, which is like over here someplace, is called Bad Astronomy. Oh, I'm pointing in the camera. And of course, people are listening. They can't see me. But it's behind me on my bookshelf.
I do it all the time.
And available at bookstores online everywhere. It's called Bad Astronomy. And so
Good plug.
people
Good
started
plug.
calling me the Bad Astronomer. And I thought, I like that. I think that's okay.
So it's more of a misnomer than anything.
Yeah, and some people call me the Bad Astronomer, and I'm okay with that too.
I mean, that's a pretty good one. You have a pro wrestling name built in.
True.
So there you go.
Oh, I'm gonna take you down, Bad Astronomy.
By the way, don't feel bad about long form answers. We're fans of Kevin Smith, and if you know anything about him,
yes,
you could ask him one question, and 40 minutes later, he's like, question number 2.
Yeah, I get a lot of when I do interviews, and I'll apologize afterwards. Say, you asked this question, and then I took 10 minutes to answer it. Like, that's fine. We can cut it down. It's easier to cut stuff down than to fill dead space. So
we're also both forever students, so we like to be
yeah.
educated. So teach.
Yeah,
please.
But you
brought
brought up
things.
the moon landing, which that was something I wanted to ask you about, right?
Sure.
So I 100%. I'm one of those people. I know we went there. I believe we went there. But I had a question where I had actually tweeted and asked Neil deGrasse Tyson about 5-6 years ago why we hadn't been back to the moon. And he responded saying almost verbatim that the technology was kind of lost to us now and that it was too expensive. But we're planning on going to Mars. So like I don't fully understand that. Like, how could we have lost the knowledge that we had about going to the moon, but we're talking about traveling further now?
Well, to tell you the truth, I'm not totally sure why we're going to Mars either. But that's
I haven't figured that one out.
The
there are better places in the universe to go.
Well, a lot, yeah. That answer is true in part. It's not the whole answer. I mean, the real answer is that there's no political will. After the first and second moon landings, the public wasn't that interested in it anymore. And Apollo 13, which famously had an explosion on board and then couldn't land on the moon, they made a whole movie about it. That brought interest back to the Apollo program again, but it waned very quickly. And even by then, the government was sort of reading the pulse of the public and saying they're not that interested in doing this anymore. Why are we spending so much money doing it? And the problem there, the basic problem with Apollo, and let me tell you something. I've read dozens of books about the Apollo program. My father worked on the Apollo program. I watched Apollo 15 launch when I was a wee little kid. We went down to Florida and I watched it go up into space. So it was pretty amazing. But the problem with Apollo is that its overall goal was to beat the Soviets. It was a race to get there before the Soviets did, to show the world that we had this technology. Because up until then, the Soviet Union was kicking our ass technologically in a lot of stuff. But then they started to fall behind, and they were going for kind of stunts in space. Whereas the United States was making progress, doing the steps necessary to figure out how to get to the moon. And so the U.S. got there first, and then they planted the flag, and then they were done, right? It was a space race. And what do you do after you win the race? You go home. There was a lot of science and a lot of great stuff that came from Apollo. And a huge fan and everything. I just wish it had been done sustainably so that we could have continued to go back. If you ever watch the show For All Mankind, which I think is on Apple Plus, it's an alternate history where we kept going back to the moon. And it's a pretty good show. But I kind of wish that had happened, and it didn't. And so NASA focused on the space shuttle, which orbits the Earth, doesn't go to the moon. The plans for the Saturn V were lost. It was, there were no computer storage facilities like we have now back in the 1970s. And just the plans for a Saturn V would have filled a warehouse. It was just a huge amount of data. And there was no money to do that. So they just kind of threw everything away. So yeah, we lost that knowledge. You're right. But in the meantime, rocket technology moved on without the need to get to the moon. We didn't have these gigantic rockets. We have smaller ones, but we learned how to do it more efficiently. Computer modeling, better engineering, better technology, better material science to build all this stuff. And, SpaceX came along. And Elon Musk did not found SpaceX. I'm just going to throw that out there. He claims he did, but he didn't. He came in later and helped fund it. But be that as it may, they figured out how to build these rockets, and the Falcon 9 is one of the most successful rockets of all time. Now they're building Starship, which I'm kind of give and take on. It's like some of it's really cool, but I'm not hugely a fan of how they're doing it, breaking environmental laws and doing all that kind of stuff. But it is a gigantic rocket that is capable of taking people to Mars if done a certain way. So yeah, it's now possible again. There seems to be a political will to do it. I don't think NASA's necessarily doing it the right way. It's a lot of money, and I don't think the goals are as clear as they could be. But be that as it may, technologically, we can do it. But I don't think they've really thought through things like, what if somebody develops high blood pressure on the way to Mars? They're 6 months into their journey, of an 8-month journey, say. Now they've got high blood pressure. How are you going to get this person blood pressure medicine?
Yeah.
It's going to take a year to get it there. What if somebody's developing a serious problem medically that they need pills for? What are you going to do? And there's been nothing about this, studies by NASA or SpaceX or anybody.
Aren't there other issues too that you have to deal with going to Mars? I mean, you have a radiation issue, you have solar radiation.
Yeah.
That you, once you get out of the magnetosphere, you're pretty much exposed to all these things. Wouldn't that?
Yeah, the sun blows off a lot of radiation. There's also radiation just in space, cosmic radiation it's called. And this stuff is dangerous. It can be mitigated if you, a lot of it's absorbed by water. If you actually have a hull of a spaceship which has water inside of it, that can protect you. But honestly, like with the Apollo missions, they were just hoping that there wasn't going to be a big solar flare or something, and they were lucky. There wasn't one. On a trip to Mars.
That's how we got the Fantastic Four.
Yes, exactly. And then you have, Mr. Fantastic piloting your rocket back.
Yeah.
But, you go to the moon, it's a 3-day journey. Going to Mars is 6 months to 9 months, depending on where the planets are in their orbits. And so that's a problem. What if a woman gets pregnant we have no idea, none, about the gestational issues of being in low gravity. There's a great book, I have it someplace, I won't look for it, called A City on Mars. It's written by Kelly and Zach Weinersmith. If you're familiar with the cartoon Saturday Morning Breakfast Cereal, the webcomic, Zach draws that. But they write these incredible books, and A City on Mars talks about all of these issues of going to Mars that have not been studied, that are absolutely critically important, but they're being completely ignored. All the sociological and medical issues, and the political issues as well.
I got one more question about this. I don't want to stick on it
too long. We have time
for
apparently, so that's fine.
Yeah, we do, but it would be an absolute
got as much
waste
time
of
as we
having
want,
somebody like you here. And please feel free to absolutely own me if you think this is stupid. But I've always had a theory in my head, wondering if, because of the way the U.S. government works sometimes, is there a chance like we lied about when we got there? Like, I know we went. I believe we went. But would it be beneath us to lie and say we got there before we did, just to win the Cold War?
Oh, so like Apollo 11 and 12 were faked, but 14 was real?
Something like that.
Yeah. there have been some.
Again, if that's stupid, please just tell me.
It doesn't make a lot of sense. There have been some conspiracy theorists, and I back in the day in early 2000s, I dealt with all these guys, and it was mostly guys. Actually, the top 4 people promoting the fact that the idea, I should say, that the moon landings were fake. There were four people that were getting on the news and getting all the interviews and doing all these shows, and they were all crackpots. And one of their bizarre ideas was that the first mission was faked. There was no way we could have gotten to the moon by Apollo 11, but the later ones, those were real. Or the flip side is Apollo 11 was real, but they faked the later ones and just took the money. There's all these contradictory ideas, but none of it makes sense. If you understand the science and the engineering, people say, it's not exactly rocket science, like rocket science is super, super hard. It is, okay, to someone who is not, taken the math and the physics and the science. But a lot of rocket science isn't that hard. A lot of it boils down to some math that you could learn in high school. And when you understand that math and you look at the Saturn V rocket, you're like, yeah, that could go to the moon. So if you're faking going to the moon, why would you build a rocket that can actually go to the moon? And all of the science, all of the images, the footage, the people involved, just all of this holds together. There's no hole in this where you say this is where it was faked. And so in critical thinking, in terms of logic, in terms of thought processes, you have what's called the null hypothesis, just sort of your basic idea. And it's the one you start off with. And the one you start off with here is that, yeah, we went to the moon. And when you start that way and you look at it all hangs together. These conspiracy theories don't make sense. They make claims that are silly. They rely on anecdotal data or people not understanding some basic things about photography and radiation. And yeah, in the end, yeah, it went exactly as it was said. We have all the documentation. Apollos 11 through 17 minus Apollo 13 went to the moon and brought these people safely back to Earth.
So getting a little beyond the moon now, you did work on the Hubble telescope, correct?
Yes.
Tell us about that a little bit and what kind of experience that was.
So I should say that's not beyond the moon. It looks beyond the moon, but Hubble's in low Earth orbit. It's actually
I'm opening us up to the wider universe a little bit.
Okay, yeah. I'm saying it's actually it gets closer to you than I am to you right now. When it travels overhead, but
it's only a few miles up.
Yeah, it's like 400 kilometers up, I think, so 300 and something miles. It's not that far up. I worked on Hubble data right after it launched in 1990 for my PhD. I was kind of scrambling around. I just finished my master's and I was scrambling around for a PhD topic. And one of the professors actually here at the University of Virginia, where I live now, said, listen, I've got this thing I'm working on with Hubble. If you want to be a part of it. I was like, absolutely. Are you kidding me? And I spent like 3 weeks really boning up on this telescope, learning everything I could about it. And then it launched. We got our first images back, and then I was looking at them. And it was of the object I wanted to look at. I mean, it was the team was looking at a star that had exploded in a supernova. And this is something I wanted to study. And we got these observations back. And it was about, 4 days after looking at them, studying them. I went up to my professor and I said, I think there's something wrong with the telescope. And he was like, yeah, we've just discovered that the mirror wasn't built correctly and everything's out of focus. And a lot of people don't remember this.
You're the one that discovered that.
No, I discovered. No, I just realized it on my own. And then it was like, yes, we've already seen this. Nobody's, everybody's kind of in a panic about it right now.
So they were kind of like,
remember that
yes,
now.
Phil, we know.
Yeah. And it was something you did. Oh God.
I wasn't even here for that.
Yeah.
You sneezed on it. What'd you do?
So yeah, it's funny. People don't really remember that it was 5 years ago now.
But wasn't it that there was something about the way that the lens was formed incorrectly, right?
Yeah, it's a mirror. It's got a certain shape.
The mirror. Sorry.
Yeah, that's okay. A lot of people say lens, and I get it. People aren't used to mirrors being used in telescopes, but that's what big telescopes use. It's not a flat mirror. It's actually curved in a parabola typically, although there's a lot of other shapes you can use. And that focuses light the same way a lens does. But It has advantages over lenses. I won't go into details, but most big telescopes, actually every big telescope now uses a mirror, and they had just ground it to the wrong shape. They had designed it to a little tiny bit off, and it wasn't very much, but it was enough to make things out of focus. Years later, they launched a correcting device that actually focused it, and then over the years, as they replaced the cameras on board, the cameras themselves could correct the optics internally. So it's like having reading glasses on each camera. So now, these images you get from Hubble are perfectly focused and they're gorgeous. So yeah, I worked for, 4 years on Hubble data of that star, got my degree, and then got a job working on a camera that was being built to go onto Hubble called the Space Telescope Imaging Spectrograph, or STIS. And it was a very sophisticated camera, and it was basically in pieces when I started started that job. And my job was to understand how they all work together and what happens. Light comes in one end, and basically digital image comes out the other end, and what happens in between. That was my job. And we launched it. It went up on a space shuttle. They installed it, and it is still up there taking data. And that's awfully cool to think that 25 years later, 27 years after that thing was put up on the telescope, it's still up there working. Pretty amazing.
You have your fingers in a piece of history. That's pretty cool.
Actually, it's funny you'd say that, because one of the instruments that STIS replaced, there's a limited amount of room in the back end of that telescope, and each camera is about the size of a phone booth. So they pull one of these things out, put the new one in, and then bring the old one back to Earth. The camera we replaced, one of the two cameras, was called the Faint Object Spectrograph, and it was sitting at Goddard Space Flight Center when I was working on STIS. After STIS had launched and everything, we were still working on it, but they brought this camera back, and it was sitting in a warehouse. And I saw it one day, and I walked up to it, and it's like, oh wow, look, it's a Faint Object Spectrograph. It's a $90 million camera. It's just sitting here. And I had a friend of mine take a picture of me. I brought wire cutters in the next day. And I walked up to wire cutters. I made this face and held up the wire cutters to a wire, and it was like a joke picture. So I literally had my fingers in history there. But yeah, that's what happens when you give an astronomer freedom to do whatever they want. It was pretty cool. It's in the National Air and Space Museum now, so it's kind of fun to see it there when I go.
You've triggered a question for me. What exactly is a spectrograph?
So when you see a rainbow, that is a spectrum, right? The electromagnetic spectrum is just light. It's a fancy word for light. And the visible spectrum is the kind of light that we see. And it's white light basically coming from the sun, but it's made up of all the different colors. So red, orange, yellow, green, blue, violet, Roy G. Biv, if you remember that from middle school. And when sunlight, which is made up of all these colors, goes through a raindrop and it bends, each color bends at a slightly different angle. That's just a basic property of how this stuff works. And so these colors get spread out in the sky and you see a rainbow. Well, the spectrograph does the same thing. And there are different ways to do it. You can use a prism, like a prism breaks up colors. You can use what's called a grating, which is like a piece of glass or metal with extremely fine lines etched into it. And when light hits it and bounces off, it breaks up the light into colors. And you can do this and break up incoming light into not just like 7 colors like the rainbow, but thousands, hundreds of thousands of colors, very, very narrow individual slices of color. You're like, well, why do that? And the answer is because when you do that and you look at astronomical objects, different things like hydrogen, oxygen, carbon, they give off different amounts of light in different colors. So oxygen tends to glow in green, hydrogen glows in red, carbon ultraviolet and infrared, I think that's right. And so if you have a spectrograph, it can measure how much light is coming from, say, an exploding star. And you can identify the elements that are in it. You go, oh, look, it's got this much oxygen, this much sulfur, and all that kind of stuff. And you can learn about what's in it. You can learn about how quickly it's moving. You can learn about its structure better. You can learn about how it formed and how it's evolving. There's a ton of stuff you can learn by using a spectrograph, by basically breaking up this light into colors and measuring it. And in fact, the fact that the universe is expanding is one of the biggest results we've ever had from a spectrograph. We measured the spectrum of distant galaxies and learn that they are all moving away from us. And that's the sort of indication that the universe is getting bigger every day.
You're muted.
You're muted, Tristan. There you go.
Sorry about that. We got the dog chewing on a toy in the background, so sometimes when I can hear it, I mute it because.
Oh, that's fine. My dogs barked earlier. I don't know if you heard that.
Yeah, see, we got Charlie back here.
He's our third co-host.
Oh, nice.
But no, I love that you keep saying things that are triggering questions that I had, because you talk about the size of the universe. Like, if any at all, what do we know about the boundaries of the universe as far as size goes?
That's a complicated question. And the reason is because we're inside of it. The universe is literally everything. That's kind of its definition. And so we can't be outside of it looking in. And when you ask, like, what's the boundary of the universe, it gets into really weird geometry and relativity and stuff. And you think, well, it's got to be an easy answer, right? The universe is so big. It's like, well, no, the thing is, over 100 years ago, a little over 100 years ago, we didn't know that much about the universe. And kind of the going idea is that it was infinite in time and space. It always existed. There was never a start time, and it was just infinite in size. And then Einstein came along, and some observations came along. Edwin Hubble, after whom the Hubble Space Telescope is named, figured out that the universe is expanding. And that raises a bunch of weird questions. Like, if it's getting bigger, what's it expanding into? That's like one of the first questions I always get from people. And it's like, well, it's not expanding.
That's always bothered me as well.
Yeah, and it's not expanding into anything. That's sort of a three-dimensional way of thinking. If you inflate a balloon, it's getting bigger in space.
So it's more like the contents, like the stars, the planets, and everything expanding out into the nothingness that is the universe.
But that's not really right either, because it is the universe itself that is expanding. The distance between galaxies is growing, but the universe itself isn't expanding into anything. It's just getting bigger.
Yeah.
And it's like, wait, what? And it turns out if there's some math you can do, very complicated math, that kind of shows that, yeah, it's possible for things to get bigger without them getting bigger into something. It's expanding, but not expanding into anything. The universe is all there is. And trying to describe this is very difficult because our words don't do well with these kind of concepts. The math describes it perfectly. And if you understand the math, which honestly, a little over my head when you start really looking at this stuff in its complexity. But the math does explain it. But when you try to describe it, it's like, I tell people, it's like listening to Beethoven's Fifth Symphony. And the music is a thing in itself, and you can try to describe this music with words, but without singing it. How do you do that? Like, words aren't adapted to do that sort of description. It's the same thing here.
Well, and our brains can't really wrap around some of the concepts of the size, the ginormity. I know that's horrible.
That's a perfectly cromulent word.
but the just absolute massive size of just our solar system.
Yeah.
And then our sun is tiny compared to the largest star that we've observed.
That's correct.
And that's just what we've observed.
Yeah.
And then you've got the black holes that are even more massive than the biggest stars we've observed.
Yeah.
It gets to a point where it's hard to fathom. I mean,
what's funny to me,
your brain.
What's funny to me is that of all of this, the size and scale of the universe are the easiest things to talk about, because we can describe that with words and numbers that you're familiar with. Now, grasping the scale, that's a different situation. Literally, like grasping, like wrapping your head around it versus just, I can write down these numbers and say, oh, this galaxy is 2 million light years away. And it's like, well, what is that in miles? And it's like, well, 2 million times 6 trillion is 12, whatever, quintillion, I think. And it's easy to write those numbers down and talk about that and do the math. But to actually think about it, it's like, it took 3 days for the astronauts to get to the moon on the fastest thing available that we had at the time. And even now, it would take a long time to get people to the moon. And the sun is 400 times farther away. If you were to, hop aboard a 747, if you could fly it to the sun, it would take 70 years or something like that, upwards of a century to fly to the sun. Think about going to Australia and it takes 12 hours and you're like, oh my God, I just want to jump off the plane. It's taking so long. And now think it would take a century to get to the sun. And that is the closest star by a factor of, I don't even know, close to a million, something like a million.
I feel like that's about how long it took me when I was a kid to drive from Chicago to Florida with my grandparents.
Oh God. Yeah.
Yeah. Stopping at every Cracker Barrel along the way. And
oh my gosh. Yeah. Getting those the bacon beans or whatever they were. Yeah, so good.
And the really weird brown gravy.
Yeah,
sausage
I've eaten a few places like that. But yeah, I mean, and that's, time is relative, right? What Einstein was talking about is actually really true, that time does change depending on your situation. But honestly, yeah, I mean, the amount of time this is a good point, because the amount of time that we experience, 1 second at a time. And when you're a kid and I remember having to drive to camp 4 hours across Virginia, and how boring that drive was. Oh my God. And so that's what we've evolved to comprehend. And the amount of distance that we've evolved to comprehend is measured in feet and miles, not measured in hundreds of millions of miles or numbers you're not even familiar with. I mean, people, not too long ago, not many people needed to know the number 1 trillion or even a billion. And now we have billionaires. Now we have, a billion bytes of data on our computers, and we're getting up to terabytes, which are a trillion bytes. So a trillion is now getting into the public consciousness, but there are numbers beyond that. Quadrillion, quintillion, sextillion, septillion, octillion, nonillion. We need these in astronomy. These are the numbers we would deal with all the time. And we're just not evolved to grasp that. So Kip, your point is true. It's hard to get your head around it. And that's nothing compared to the bizarre stuff of, like, how big is the universe? How, and there's how far we can see in the universe. The most distant objects we can see are close to 14 billion light years away. But that's because the universe is only about 14 billion years old. You can't see anything farther away because the universe isn't old enough for the light to have reached us from any farther than that. And in the meantime, the universe has been expanding, so those objects are farther away now than they were when they emitted that light. So now they're actually, 40 billion or whatever light years away, if you want to think of it that way. So
eventually we're not even going to be able to see some of the things that we can see now.
That's true. Actually.
If we were to live longer. Yeah.
Yes, if you were to live for a few billion more years, that might be a problem. And so, so these concepts are so strange. And even to astronomers, there are times we sit back and go, well, that was bizarre. Why is the universe doing this? It's a fun thing to try to explain it to people. Sometimes, like we're just talking here. But when I'm writing, I realize, I can't do this. I don't have an infinite amount of space to do this. I've got 1,200 words to get my point across. And if I start talking about relativity and cosmology, my God, I've already lost the track completely.
So how does dark matter and dark energy fit into that? I know they're concepts that we haven't quite been able to prove yet, but everyone says it exists.
I would say dark matter is proven beyond reasonable doubt. I would say dark energy is close to that. I don't know. I don't think we're going to find out that our ideas about dark energy are completely wrong. The problem is we don't know what these things are. We know they exist, but we don't know what they are. And that's the problem. Dark matter comes up, and it's basically saying that the universe has a certain amount of stuff in it, mass. You can think of mass as weight. It's different, but it's similar. And so, the sun has mass. It has 300,000 times the mass of the Earth. If you want to think of it that way. And there is a certain amount of mass of a galaxy. The problem is mass is what dictates gravity. So the more mass of an object you have, the more gravity it has. Galaxies have a certain amount of gravity. And we can measure that by observing how quickly the stars are going around the center of the galaxy. If it has a lot of mass, has a lot of gravity, those stars are whizzing around really quickly. And if it has less mass, less gravity, the stars don't have to move as quickly. And so you can measure this. And what happens is when you look at the amount of light a galaxy is emitting, and you measure up its mass and you go, well, that doesn't work. It seems to have a lot more mass than the light it's emitting. And the light it's emitting is mostly coming from stars, but stars dominate the mass of a galaxy that we can see. So what we're finding, and this has been known now for many, many, many decades, that most of the mass of a galaxy must be dark. It must not be emitting light, but it's there with its gravity. So what is it? Well, maybe it's dead stars. Maybe it's planets wandering around. Maybe it's black holes. And the problem is all of these things would have predictable effects that we could measure, and we don't see it. So we have this checklist of things dark matter could be. And basically, we're at the bottom of the list now. It's like we've eliminated everything we can think of, and what's left is really weird stuff. Subatomic particles that have never been discovered, but that kind of fit the idea of what dark matter could be. Maybe black holes, maybe. And so the thing is, we see dark matter in galaxies. We see dark matter in clusters of galaxies. Galaxies like our Milky Way live in clusters. There can be hundreds or thousands of galaxies all orbit around each other. We see the effects of dark matter there. It fits into our equations of how the universe works. We know it is there. We're not making this up. It exists. What is it? That's the question. And it's similar to the ancient Greeks, who were like, matter exists. This is a solid rock I'm holding in my hand, but what's it made of? And this one guy came up with the idea, I'm blanking on his name. Democritus is what I'm thinking. I know that's not right. But Democritus? Anyway, came up with this idea that if you cut a rock in half and then you cut that half in half and you keep doing that, eventually you'll get down to this little bit that you can't cut in half anymore, which we will call the atom. And it turns out pretty close, pretty right? But they couldn't see atoms, and yet we knew matter existed. It's similar now. We know dark matter exists. We just don't know exactly what it's made of. Dark energy is way more complicated, but it's the same sort of thing. We see the effects of this weird thing going on in the universe that seems to be pushing on the universe and making the expansion accelerate. So not only is the universe expanding, every day that expansion is getting faster. And so there's this energy in the universe that is doing that. It's hitting the gas, basically, on this acceleration. But we have no idea what it is. And we are building telescopes now to study it and try to figure it out. But we're right now at the point where we just don't know. So see what I mean? That was probably like 1,500 words right there. And it's,
you just wrote a paper.
You kind of need to know what galaxies are and gravity and all this stuff to figure this out. And that's what makes being a science communicator fun. And that's why my answers are so long.
Yeah, but you know what? You're teaching the average person who really wouldn't have the time to study this themselves all about things that are so fascinating. Because to me, the universe is like we said earlier. There's so much going on, and the size of it and everything. Just that alone, like wrapping your mind around some of this stuff, is just fantastic. And there's an infinite amount of things that you can explore and look at to learn about and be like, holy crap, this is amazing. So like what's the most fascinating thing that you've learned about the universe over the years where you're like, oh my God, like check this out, you'll think this is cool?
Oh, there's so much. One of my favorite things, I have her permission to tell this story. So the actress Emily Hampshire, who was in Schitt's Creek and 12 Monkeys and is now making a bunch of movies. And if you saw her, you know her right away. She's terrific. Years ago, I moderated a panel on the 12 Monkeys TV show cast, and she was there. And afterwards, we went out to dinner. And she asked me the same thing. She said, what's the coolest thing you know? And I sat back for a second, and I thought, okay, when the universe first formed, this is going to take about a minute and a half, maybe. When the universe first formed, all it was made of was hydrogen and helium, the very simplest elements. There was no carbon, there was no oxygen, there was no calcium, none of that, just hydrogen and helium. This coalesced to form stars. And some of the stars were small, like the sun, but some of them were very big, much more massive. These stars in their cores would convert that hydrogen and helium, like a nuclear bomb, into heavier elements. So the hydrogen fuses into helium, the helium fuses into carbon, the carbon fuses into oxygen. And the core builds up with all of these heavier elements. And eventually that star explodes and it scatters that material out into the universe. And then the next generation of stars is born with that material already seeded into it. Gas clouds absorb this material coming off this exploded star. The gas cloud collapses and forms new stars. And you get the second, third, fourth generation of stars. And the sun is one of these later generations of stars. And it formed planets. And we live on one of these planets. And so, all of the iron you see around us and all of the iron in your blood and the calcium in your bones. And as soon as I said that, Emily's eyes got as big as dinner plates. And she went, all of these elements were created in exploding stars. And I was like, hands up in the air, success. And it was a moment of connection.
We're all made of stardust.
Got it. And she's not a science person at all. But in her head, she made that connection. Yes, exploding stars are the reason you exist, that you can exist at all. And that is something that we learned through astronomy and through a lot of other physics, through chemistry and nuclear physics and a lot of other stuff. But all this came together to teach us that, when Carl Sagan said we are star stuff, that is literally true. That all of those heavy elements in your body were made in massive stars that blew up long before the sun was even born.
I love that you brought that up, because that's always been one of my favorite things too, is, that basically everything that we know, everything's made up of elements that came from exploding stars. That's fantastic.
And different elements come from different things, like gold and strontium and platinum and a few others come from a different kind of exploding star than the massive stars that blow up. And most of our calcium comes from a third type of star that blows up. That's not like the other two. So it's all of these things mixed together. And it's just tremendous to think that the universe itself has generated this complexity, that it started off as just kind of this soup of radiation. And now we have life and just complex things out there that are way more on a much higher level, I would think, than just the simplest hydrogen and helium that we had 13.7 billion years ago or something like that. It's pretty amazing.
I can almost understand how our planet and us developing life and becoming what we are now, I can almost see how that's with all the pieces that have to be in place in order for that to happen. I can see how special, I can understand how we can believe that we are incredibly special as becoming thinking, life forms out of the primordial soup. That
right.
I can understand that. That makes perfect sense to me, but I also think it's kind of ignorant to think that it didn't happen somewhere else. You know what I mean?
We're just now getting to the point where we can discuss this scientifically. It's always just been speculation. In the 1950s, they were doing experiments in chemistry to try to figure out, what was life, or what were the conditions like on the early Earth, and mimic them and see if you can get life to arise. The Miller-Urey experiment, that's called. You can look that up. It's pretty cool. But we don't know exactly what the conditions were like on the early Earth. We kind of know what the atmosphere is made of, but not 100%. We don't know exactly. And so it's hard to say. And there's a lot of arguing about how life got how molecules got more and more complex to the point where they could replicate. And, you have a molecule that can then absorb other atoms and replicate itself. And, do you need lightning as an energy source? Was this happening in tidal pools where, on the coastline where water would splash in and then it would sit in its own little juices for a little while and be able to stew, or how this all worked? And so we're starting to figure that out. Plus, now, in 1990, we didn't know of any other planets in the entire universe except for the ones in our solar system. And by a year or so later, we were starting to discover them. And now we know of thousands. And we're predicting statistically by, we see so many planets around so many stars that if you extrapolate that to all the stars in our galaxy, planets may outnumber stars. There are some hundreds of billions of stars in our galaxy. There are probably more planets than that. And if you think about it, well, the sun has 8, 9 planets, whatever you want to call a planet. And there are, so why shouldn't many stars have multiple planets? So that's a big thing right there. if there's life out in space, the way we think of it, you need planets. Well, now we know they're there. And now we've taken the next step to actually starting to characterize some of these planets. We're looking at them and figuring out how big they are, what their gravity is like, whether they have atmospheres. We can actually detect atmospheres on some planets orbiting other stars. This is mind-blowing to me. The detail of data that you need to do this is extraordinary. And yet we can do this now with telescopes like JWST, the big telescope NASA launched a couple of years ago. So we're getting to that step too. And soon we'll be able to look at smaller planets, Earth-like planets, maybe orbiting other stars, and wonder, were conditions on those planets similar to Earth? We don't know. Even in our own solar system, there are moons of Jupiter and Saturn that may have liquid water oceans underneath their surface. They're frozen on the surface because they're so far from the sun. But underneath, they're warm enough to have liquid water. We know this. We have detected this water. Liquid water? And maybe a rocky core that could give the minerals that you need for life? Could there be life on Jupiter's moon Europa and Saturn's moon Enceladus? It's not silly to wonder about that. This is becoming a science. And then the question is there intelligence? Well, the big question is, does life exist out there? Most astronomers, most scientists are like, yes, that's the way to bet. But is there intelligent life? And that's a whole other problem. And that's something we have very little grasp on right now.
Well, because it's odds are life on other planets isn't going to look anything like us. It's not like Star Trek where as Kirk travels around the universe, everything's kind of humanoid, walking erect with 2 arms, 2 legs,
but blue and green and
yeah.
Well, then 30 years later, we found out that basically all aliens look just like humans, except they have like ridges on their nose or their forehead. Yeah. So that's what Next Generation brought. That's a budgetary limitation, not an imagination one.
That just makes it easier to fight or fornicate with them. So
yes,
Michael Westmore did a fantastic job coming up with different alien designs. That's all I'm going to say.
Yes. Actually, there was a Star Trek animated series too in the 70s that actually had some pretty wacky, different aliens than the show because
you can draw it. I mean, if you can draw it, it's easy. But
look on Earth. In the oceans, there isn't intelligence, not like ours, but squid and octopuses, which I think is the correct. I don't think it's octopi. I think it's
octopi.
Octopod?
Is it?
I don't know.
Octopi is what I've always heard.
More than one octopus, I'll say that.
Yes.
There you go.
They have an intelligence, and they are not shaped anything like us. Now,
their problem-solving capabilities seem like insane for what they are.
Creepy. That's why I stopped eating calamari. It's like, these are intelligent. I don't want to eat them anymore. And
plus, if you don't eat it fast, it gets a little rubbery, and then it's not that good. So
there was a theory I heard about octopi or octopuses or however you want to say it, that they may actually be alien life.
Yeah.
Because of how weird their thought processes are and their problems.
Yeah, and it's like, it seems that pretty clear that they evolved on Earth. When you look at their DNA, they share the same sort of evolutionary history. You can trace that all back. But the point you make is interesting. Like, there are things that are similar and things that are very different. Their environment is underwater, so they don't need rigid bones to stand up. If you live on land and you want to be bigger than an insect, you need something solid to prop you up. Just like a building needs, a tall enough building, you need steel I-beams and that sort of thing to support its own weight. But in the ocean, you don't need that. So you also don't necessarily need the kind of design where you can see forward as opposed to being able to see all around you. There's more of an up and down in the ocean than there is on land. We live on the surface, and that's pretty much it. And so we're evolved to fit our environment, whereas they've evolved to fit theirs. And theirs is very different. So they're very fluid. Their tentacles can move different than we do, but they still have eyes. And it turns out eyes are a really good evolutionary adaptation to sense your environment because things give off light. Unless you're in an environment that's dark, like a cave or at the bottom of the deep ocean, eyes are a really good way of seeing what's around you, of detecting what's around you. And the eye evolved. We kind of understand in many ways how the eye evolved. A lot of people who don't believe in evolution argue against this, but they're wrong. In fact, just being able to sense something is light versus something being dark is helpful, because that lets you differentiate between day and night. And then as that sense gets better and better, it can basically evolve into an eye. And the eye has evolved several times in different animals. You know, we see animals that when you trace their history back, the eye must have evolved independently of each other in these two different animals. And yet here we are with very similar devices to sense light because of the physics. There's just a certain way to sense light, and certain ways, you know, a lens is a good way to magnify things and focus it. And so evolution has discovered this over and over again. So if we go to another planet and life is there, it is entirely possible that they will be incredibly different than us. They might not have two legs. They might not have two arms. They may be able to see in all directions instead of just ahead of them like we do. But will they have eyes? You know what? If their atmosphere is like ours, transparent to the kind of light that their sun emits, and so everything up around them is lit up, yeah, they may have eyes or something very much like it, because that's just the best way to do it. And evolution tends to find the best way to do things.
There are going to be similarities that we cannot deny.
Yeah. Sound is another good way. You know, if you communicate by blinking your eyes or by sign language, say, it's hard to communicate that over a very large distance. I can shout for a long way, whereas somebody signing might be harder to see. Now, I'm not saying one's better than the other. I'm just saying that if you're evolving a way to communicate, using light is a good way to do it. Using sound is a good way to do it. And then as that develops, you learn other ways. If you can't see very well, you can't hear very well. But evolution will find those ways to do that. And that's why we can sense heat on our skin, why we can hear things, see things, taste things. These are all ways of sensing our environment. And it's, an alien, there are not that many other ways to sense your environment. And so if aliens exist, they may very well have the same sort of sensory organs that we do. I'm just guessing. I'm not a biologist, but it seems logical that that might be the case.
If anything, I think it would almost be creepier if they actually looked like us.
Oh yeah, if they evolved along the same line, billions of light years away, that's terrifying.
Well, you know, the thing is, a lot of our design, and I hate to use the word design because that implies a designer, but I mean, the way we are put together makes sense for a hunter. You know, our eyes are ahead of us so that we have binocular vision. We can sense distance pretty well. We have arms and fingers to manipulate our environment around us. Tentacles would do that as well, but they can't support that much weight. And so we look the way we do for a lot of evolutionary reasons. But there's a lot of calcium that is around that we could use to develop bones. And it makes me wonder, like on another planet, what if they have iron and no calcium? Will they have bones made of iron? And if they are, how big can they get? A lot bigger than us, because iron is much stronger than calcium. So who knows?
That's
they may look like us, they may not, but there will be similarities. There will have to be, I think.
Where are we at on what we know about Earth-like planets?
Well, of the 6,000 or so planets that have been discovered, a fraction of them are about the same size of Earth. I don't know the exact fraction, but it is some, amount, 5% or whatever, some number of them. Most of them are big gas giants like Jupiter and Saturn, or Neptune and Uranus. Actually, many of the planets are sort of in that range. And there are a number of Earth-sized planets out there. We also know of a lot of planets that are orbiting their star at the right distance to have liquid water on their surface, which is what we think you need for life. Maybe not. Maybe there are other things you can have. But we know water is important to life on Earth, so let's start there. And some of these Earth-sized planets are in that zone called the habitable zone from their star. The problem is these planets are very tiny compared to the star. I mean, the Earth is 1% the width of the sun. 109 Earths could fit across the sun's diameter. The sun is immense. And so observing a planet like that is difficult. Bigger planets are easier to see. They're easier to get our data on. So we know very little about the atmospheres of any of these planets. But we're getting better at this. There's a star called TRAPPIST-1. TRAPPIST is an acronym. I can't remember what it stands for, but it's transiting planet something. It's actually named after the Trappist monks who make this kind of beer that the astronomers really liked. And so they called their telescope TRAPPIST, and it's discovered this star, or it observed this star. It's about 40 light years away, which is very close on the scale of the galaxy. The galaxy is much larger than this. This is a nearby star. And it's a red dwarf. It's a dinky little dim star. You can't see it with the naked eye. You need a big telescope just to see it at all. And it has 7 Earth-sized planets orbiting it. And the inner 2, B and C and D, I think, the 3 innermost planets, I think, are too hot to have life as we know it. And the outer 2 are too cold. But there are 2 or 3 that are close enough to the star to have liquid water on their surfaces. And there's a big push right now to try to figure out how to study them better. Because these stars are very common. They're far more common than stars like the sun. And we're learning, yeah, these little red dwarfs are really good at making small rocky planets. Most of the rocky planets in the galaxy are likely orbiting red dwarf stars and not stars like our sun. And so do these planets have atmospheres at all? Do they have atmospheres like ours? Are they water worlds? How do they work? And this is a big, big field right now in astronomy and planetary science, too, to figure out how this works, because they are very common. There could be billions and billions of planets like this in the galaxy. They would far outnumber planets like Earth, and yet they might be just as clement for life as Earth is.
Bringing us back into our own solar system. I just got a couple more questions before we wrap this up.
So 2 more hours. Got it.
What do we know about Planet 9?
Oh yeah.
Oh, that's one of my favorite ones.
Yeah. So
I love solar system conspiracy theory type weird science stuff. So
I was sitting here when you asked that. I'm sitting here thinking, well, which Planet 9 do I want to talk about? Back in the
not the crappy animated one.
Oh, Duck Dodgers, Planet X.
No, I think The Rock made an animated movie called Planet 9 once.
Oh, I don't think I know about that one. I know.
Yeah,
Duck
nobody
Dodgers
did. That's why I know.
That just tells you how important it was, you know.
Super briefly, Velikovsky was this guy who kind of came up with this idea that everything that happened in the Bible was literally true. So Sodom and Gomorrah being destroyed, manna falling from heaven, all that stuff was literally true. And he explained it using astronomy, that Venus was ejected from Jupiter, just like the Greek myth of Venus coming from Zeus's forehead, Aphrodite, I mean. And Venus tooled around the sun like a pool ball, causing all these catastrophes as it passed by Earth. It turns out this is all nonsense. His biblical scholarship was terrible and his astronomy was worse. But it got picked up by this other guy named Zecharia Sitchin. I hate that I know all this off the top of my head. You could wake me up out of a cold sleep and I know all this. I've got about a dozen books on my shelf because I used to debunk this stuff all the time. It was my full-time job for a while. So Zecharia Sitchin wrote a series of books where he proposed that there was this 10th planet. Pluto was considered a planet then. But he called it the 12th planet because the Babylonians predicted that there was this extra planet. But the Babylonians considered the moon and the sun to be planets. So right away, we're like, not the best astronomy.
A little bit of flaw in there, but all right. Yeah.
And he talked about all this stuff. And it was all nonsense back then. He called it, I think he was the one who called it Nibiru. And then this got picked up in the 90s, late 90s and early 2000s by some conspiracy theorists, a woman named Nancy Leader, who said that there were aliens on Planet 9 that were communicating with her telepathically and telling her that it was going to pass by the Earth and destroy us all. She even gave a date of like May 15th, 2003, if memory serves. I debated her on a couple of radio shows. And then I realized like, oh, she's got issues and I'm not going to debate her anymore. It's not
You
right.
can't win a debate with someone who's banana sandwich.
I wouldn't use that term, but when she's clearly got some mental health problems, and I'm just like, no, I'm not going to do this anymore. But it got picked up by more conspiracy theorists, and that stuff's basically gone. These conspiracy theories come and go. Planet X. Oh, look, it's time for me to snack my dogs. There you go. My alarm went off. So that's all nonsense. But could there be another planet in our solar system? I mean, the conspiracy theory has it on an elliptical orbit, which passes by Earth and does all this stuff. That can't be. But you could have a massive planet orbiting the sun really far out, way out past Neptune. And even if it were fairly big, it would be so dim because it doesn't reflect. There's not enough sunlight out there to reflect. It would be dark and it would be hard to spot. And even when I was working on Hubble, one of my astronomer compatriots, Bruce Woodgate, and I were looking into the idea that maybe there was another planet in our solar system, because we were seeing planets orbiting other stars, or at least we didn't see the planets, but we saw their indirect effects on the stars. It's complicated. I won't go into it. But we saw planets orbiting stars much, much farther out than Neptune, which showed that they could form really far out, or at least exist really far out. So, hey, why not our solar system? And then it was just an idea we had. Other people had it as well. But then some astronomers started noticing that there's all of these giant, icy, rocky bodies out past Neptune called trans-Neptunian objects. And there's millions, billions of them out there. We've discovered a few thousand at this point. But when you look at them, they should have random orbits. They should be elliptical and tilted every which way and everything. And they weren't. That the orbits were kind of lining up a little bit in a way that you don't expect. And they posited that maybe there's a planet out there that is gravitationally tugging on these comets. They're kind of like cometary bodies, and aligning their orbits this way. And they're calling it Planet 9, kind of a tongue-in-cheek way of making fun of Pluto, to be honest. And the evidence is interesting. A lot of people have gone over their evidence and said, well, maybe it's this, maybe it's that. And these never seem to really fix the problems. And the best idea we have right now is that, yeah, there's a big planet out there really far out that's messing up these comets' orbits. And they're looking for it right now. And we've got big telescopes coming online in the next couple of years that will be searching the sky, not specifically looking for this planet, looking for a lot of stuff. But yeah, that planet might show up in it, and we may yet have another planet in our solar system.
I always kind of wondered that about the asteroid belt too. Was that, I mean, could that have been another planet that got destroyed during the formation of the solar system and things like that?
That was one of Sitchin's ideas, I think, that it was a fifth planet that blew up, and that got picked up in some of these conspiracy theories and some science fiction stories. But no, it's probably just rubble. When the solar system was forming, it was just this cloud of basically gas and dust, just little tiny bits of rock. And this stuff clumped together to start forming bigger objects, and then those clumped together to get bigger and bigger and bigger, and we formed the planets. The problem is, between Mars and Jupiter, you've got these objects that could have been several miles across, but they couldn't form together to get to become a planet because, I'm oversimplifying, but Jupiter's gravity was tugging on them. And so instead of colliding slowly and able to stick together, Jupiter's gravity was making them hit faster than they could. And so they would just break apart again. So you have sort of a maximum size you can get of objects in the asteroid belt. And Vesta and Ceres are the two biggest asteroids. In fact, most planetary scientists call them protoplanets. They were so big. But they basically ran out of fuel. You can't make them any bigger without shattering the asteroids. And so the asteroids are basically leftover rubble from the solar system's formation. They were never really a planet. So there you go.
Well,
it's kind of cool that we can even know that.
That is very cool.
And that's, I mean, all of these things we've been talking about here is, you ask me what's one amazing thing or another amazing thing. Really, the amazing thing is that we know this stuff. That we can look out in the universe. We are of the universe, made up of all of these chemicals that were created in the stars and in the Big Bang. And then we figured out how to look out in the universe, and we're not guessing. We're not making up myths and legends anymore. We're studying these things and going, this is how this happened. We know how stars are born. We're learning more about that every day. We had no idea how planets formed when I was born. And now we're seeing them forming. We have pictures of baby planets forming around other stars. This is science. This is what we do. We learn and figure stuff out, and we don't have to guess like we used to with very limited information. Now we have tons of information and a basis, a framework to put it in. That's science.
I love it. I absolutely love it. Before we kind of wrap up, I want to pivot just a little bit. We talked a lot about science and about the universe and the solar system and all that, but I kind of want to talk about Dr. Phil Plait for a second. Aside from astronomy, cosmology, all the things that you do for work, what do you nerd out about? Like, what's your fandom? What's your geekdom? What are you into?
That's funny you would ask. If you could see, if this weren't an audio podcast, it were visual, you would see that I'm wearing a Captain America t-shirt. Mm-hmm. Over my shoulder is a Jean-Luc Picard maquette, a little bust. I've got
I see the phaser on the shelf too.
Yeah, you can see the phaser. Yeah, I'm big into Star Trek. I've got props from TV shows over my shoulders, a prop from the 12 Monkeys show. I'm not as big a Stargate fan as I am Star Trek. Big Star Trek fan. I'm a big Stargate fan. And mostly just science fiction. I really love science fiction and monster movies and stuff like that. I always have ever since I was a kid. I could rattle off a bunch of movies that you've never heard of that are my favorites. Many of which I argue still stand up today. But it's one of the things that I love is how Star Trek has evolved, right? In the 60s, you had this TV show. It was just a TV show. And it had high moral standards and high aims, the goals of it, philosophical and political and really holding a mirror up to society in many ways, which is what good science fiction does. But in the end, Shatner himself has said it was a job. He would get up in the morning, he'd learn his lines, he'd go and do them, and it was a good job and he liked it. But to have it turn into this big movement was surprising to him. And then over the years, it's, Next Generation and these other shows, it's gotten better. And what's funny to me is that people like me were inspired by Star Trek. I loved Spock. I loved Scotty. And Will Robinson in Lost in Space. Boy, did I identify with him. Little redheaded kid, smarter than he should have been, that kind of thing. I got teased a lot for that when I was a kid, loving science so much. But then, you get this generation that was raised on these shows, and then that generation started to write Star Trek and be actors in Star Trek. And then what happens is you have people like Will Wheaton, who played Wesley Crusher in The Next Generation. He's a science nerd. After that show, he did programming. He was a coder for AOL, I think. No, Scalzi was AOL. I can't remember what Will did, but he did coding and that kind of stuff. I've been to Star Trek conventions, many of them, and Star Trek cruise a couple of times. That was a lot of fun, where you really get to sit down with these actors that you love and talk to them. And so many of them are really inspired by the science. And to see that come full circle, right? To have the show inspire scientists who then do the science that inspires the shows coming in, that makes my heart sing. And to see people like Jerry Ryan, 7 of 9 from Voyager, right? Huge megastar. She's been in all these TV shows. She's brilliant. She's funny, just a witty, wonderful, charming, warm person. She digs the science. She loves the science. She did a TV show where she had to play a medical examiner, and she went to an autopsy to learn more about it. That's who she is. And she follows scientists on social media. We chat sometimes. And so it's like to see these people who are inspiring generations of scientists, that they actually love the science. That is the geekiest, nerdiest, most wonderful thing. And it makes my heart sing. I love it. I love it.
Is it hard for you to watch stuff like that, like stuff about outer space and stuff, and not call bullshit sometimes on some things? Or can you separate and just enjoy it?
Back in the day, when I started off my website, I did movie reviews, and it turns out it's super easy to become a smug asshole. I can swear, right? I can use that word.
Oh, I can relate. Yes.
You turn into a dick when you critique movies a lot.
I resemble that remark.
Very smug and arrogant. I stopped doing that because I was like, oh wow, I'm being a real jerk here. So
you're saying we shouldn't get you going about Armageddon?
Oh my God, that movie. That was another one of my viral reviews. It's still up, and I stand by that review.
That movie was amazing. I watched it recently, and I was like, "This is piss."
I think overall it's just a terrible movie. But the science in it is garbage.
And
They
for the
went out of their
record,
way to do
I
things
think
wrong.
I think great actors can put in great performances in bad movies. You know, I'm not slamming the people in it. It's just
The script
some people are
script.
victims of bad scripts.
Well,
You know,
actually, yeah. I mean, you can have good actors in bad movies. Look at Natalie Portman in the Star Wars prequels, right?
yeah,
And Hayden Christensen, who is,
yeah.
and it turns out it's the directing that's
Yeah.
bad,
I
not the
liked
actors.
I liked Brandon Routh as Superman, but that movie was horrible.
Yeah,
You
yeah.
know?
Oh, and he's kind of a science nerd too,
Yeah,
a little bit. Anyway, so I used to do that a lot. And I learned to sort of back off of that a little bit or a lot and just go, well, I wish they could have done this better. But there's been a big push in the past 20 years to get better science in movies. And that's one of the reasons I've been to these conventions and met some of these actors and writers and stuff, is because they're contacting scientists who say, look, we're making a science fiction movie about an asteroid impact. How can we make this accurate, or as accurate as possible, given we need to have certain things happen in our script?
Oh yeah, there's certain action points that have to be hit in order to make it watchable.
And that happens. There's the Science and Entertainment Exchange is a collaboration between scientists, and the National Academies of Science backs this group, and that's the highest level science organization in the country. The Science and Entertainment Exchange has Hollywood folks and science folks getting together and talking about how to do this. And I got involved with that early on, and it's been terrific. I've consulted with a bunch of movies and TV shows. Most of them don't go anywhere, but every now and again, like the movie Arrival with the aliens that come to Earth, Amy Adams and Jeremy Renner. My involvement with that movie is complicated, but I have a credit at the end. My name's in the credits, and I gave the writer some ideas about the aliens and how they would perceive time and stuff.
I like that circular time.
Yeah.
Concept.
Yeah. It's based on a short story, which is excellent, and the movie is quite good. So I didn't have any I wasn't really officially doing consulting with it, but they used some of my ideas, which is fine. But it was just funny to think, oh, my name's in the credits. I watched the movie in the theater. It's like, holy crap. I wasn't expecting that. But some other TV shows and stuff. And I have, friends who were scientists who were involved, like the movie Gravity or Battlestar Galactica. And Marvel has been really good about getting science consultants in on their shows to get it right as much as they can, given that it's, superhero stuff. But it's been wonderful. And so, like, I watched a movie last night, The Gorge, which is on Apple Plus right now. And it's a rom-com that turns into kind of like a sci-fi horror. And the science in it, the movie kind of, I'll just say, the first half of the movie was a lot of fun, and then it just kind of falls apart.
I saw something about that recently, I think.
I'm not going to go into details, but the science in it was laughably bad. And then they started doing things that don't make any sense, and you're like, oh, God. So it's like, for me, if the science isn't too bad, I don't mind. But it's when the internal logic, it's like, why is this character even doing this? That just doesn't make any sense. That's what really brings me out of a movie. And that's what makes me angry. So I've seen a lot of movies like that lately, so it's at the top of my mind right now.
So having the wrong stars in the sky doesn't bother you like it bothers other people?
Yeah, that kind of thing.
It's one of my favorite stories that I've heard is
with Neil deGrasse Tyson.
Yeah, Neil Tyson and James Cameron, on the Titanic. In fact, if you go and watch The Expanse, which is the most accurate science fiction show that's ever been made.
Great show.
The showrunner has a PhD in physics. The two guys who wrote the books, who were producers of the show, dig the science a lot and wanted to make sure it was as accurate as possible. There are scenes in that they go out of their way to make the science right. And in fact, if you watch it and you pay attention to the stars, you'll see like Orion and Taurus and the Pleiades and all these real constellations. And they did that. And it's like, I love that. I love that show so much. It was so good.
I used to love watching disaster movies with my my ex-mother-in-law, because after you get a few drinks in there, so you watch like Armageddon or 2012 or The Day After Tomorrow, and it's just funny to watch her because she's a very logical, intelligent person, just sitting there screaming at the screen, yelling bullshit on so many things.
Day After Tomorrow got a lot of grief from people because of some of the stuff in it, and I did it too. On the other hand, this idea of catastrophic, the basis of that story is that the cycles, these conveyor belts of cold and warm water in the oceans collapse, and that brings very rapid climate change to the world. Is not that far off. I mean, it was accelerated for the movie. Really? It happened in like days in the movie. It would probably take years, but it doesn't take centuries or thousands of years. This is something that can happen very rapidly. And it wouldn't necessarily freeze the planet, and all that stuff. That was movie stuff. But the basic idea of the movie is like, okay, all right, sure.
Yeah, we have proof of that with the Sahara Desert. It used to be a lush green environment, and they've proven the fact that it turned into a desert based on climate change.
Yeah, I think that was that has to do with the way the Earth's axis points towards the sun and very slow changes in the Earth's orbital shape. The Milankovitch cycles, these are called. They take hundreds of thousands of years. But yeah, you can have slow change for a long time, and then you hit a tipping point, and then kablam. And then geologically speaking, or cosmically speaking, it's very, very short period of time. Things change a lot. And that's where we are. And so having that in the movie, I like that. I like that it showed that.
I'm willing to take the risk of that geological change if it ends up where I'm locked up somewhere with Emmy Rossum for a while.
She was great in that movie, wasn't she? I'd never heard of her, or I had heard of her as a singer. And then she shows up and is like the best actor in that movie by a long shot.
Yeah, because she was fantastic in with the Phantom of the Opera.
Oh, I haven't seen that. Okay.
Yeah, she was actually in that the film adaptation.
Oh, okay.
Of that.
But yeah, so it's interesting to me who you wind up seeing actors who really blow out of the water everything that's going on around them, and they're in this terrible movie, and you're like, how did this happen? But yeah, or you see great actors who do badly in movies, and it's like, yeah. Most actors are really good. When they get into the movies, they're really good actors. And it's the direction or production that makes them look kind of stiff or wooden or whatever.
Well,
now I'm going to get a job again by saying that. Yeah.
We've had a fantastic time with you today. We don't want to take up too much of your time, especially because we know you got to go give the dog some treats.
Oh, and I got a deadline on Monday too. I got to get to. So.
Yeah. But we like to wrap it up here with a questionnaire that was invented by Bernard Pivot and made famous by Mr. James Lipton. So, Kip, if you want to start that off.
Okay. Yeah. So, just relatively quick answers. You can elaborate if you want to. But
relatively quick question. Your answers. Yeah.
What is your favorite word?
Pneumona ultramicroscopic silicovolcanoconiosis.
That's a new one.
I don't remember Dick Van Dyke singing that one.
No. Yeah, you don't remember pneumona ultramicroscopics. It's a long word. Basically means black lung. And when I was a kid, I loved words and like puns, and that I still do. And I remember looking up like the longest words I could find and trying to memorize them just to be kind of a jerk. And that was one. And in fact, I just saw Noah Wyle, who's in the show The Pit, which is a new TV show playing a doctor. I saw a clip of him saying that word, and I was like, oh my gosh, that was pretty fun.
What is your least favorite word?
I don't know. There are a lot of clunky words. Probably. Oh, you know what? I'm coming up blank. I'm trying to think of a negative word like inflation or or we're shutting down all the science agencies in the government. Those are words that I don't like being strung together that way. But I don't think I have a least favorite word.
Okay. What sound or noise do you love?
French horn. And low clarinets. I'm a classical music guy. I like rock and I like a lot of stuff, but classical music's my first love. And anything that has French horns, John Williams, that kind of thing. Low clarinets can be very spooky and atmospheric, and so I really dig that.
that low vibrating.
Yeah, I played trombone.
Warm. I did too in high school.
Oh yeah,
played trombone
oh,
and
cool.
baritone. But
yeah, I played baritone too. It turns out baritone's easy once you learn how to play trombone.
Oh yeah. What noise or sound do you hate?
The kind of things that like that most people hate, like fingernails on chalkboard, doesn't bug me, but the idea like chewing on foil, that feeling and that the noise it makes when I hear it on TV, I'm like, oh, yeah.
Okay. What profession other than your own would you like to attempt?
Being an oligarch would be good, I think, especially now. Just being a whack job billionaire, trying to become immortal by drinking my son's blood, I think that would be okay. You don't know about this? There's a guy doing that.
No, that's
I haven't heard about that.
Yeah, when you become a billionaire, you kind of lose your mind.
Pretty sure drinking blood is not good for you.
Yeah, I don't think he drinks it. I don't know what he does.
He might be transfusing, but
he's trying to be immortal. Yeah, he's doing something like that.
He's doing a Nicky Six, just straight into his veins, like Jack Daniels.
But yeah, I mean, for a real profession, I really love writing, and I was a professional astronomer. I mean, I was working on Hubble, and then started writing, and found out I liked writing a lot more. And it turns out I was never really that good at the coding and the astronomy research side of it. I was much better at talking about it, which is why I do that now. And I've written books. I write a newsletter. I write for Scientific American. So I have all these different sort of writing jobs. I also give public talks. And back in the day, like when the egg standing stuff and the moon hoax stuff, Face on Mars, all these popular conspiracy theories were coming around, I gave a lot of talks. And I really love doing that. I love standing up in front of an audience and talking, showing pictures and talking about stuff for 45 minutes or whatever. This may not surprise you. And I'd love to be a public speaker. It pays okay. It can pay very well sometimes, but that would be, if that were something I could call my full-time job, I would be pretty happy.
What profession other than your own would you not like to attempt?
All of them. Yeah, I mean, it's like I know enough people who do different things now with social media. You have friends who are actors, who are technicians, who are engineers, and all this other stuff. And it's like, yeah, I cannot do that. I've taught mostly informally. I did teach at a community college for a year, and I've taught some other places, and it's like I cannot imagine doing this year after year, especially now where teachers are treated so poorly. They're not paid enough. They're overworked. They're underfunded. But even if they were funded well and we had smaller class sizes and all that stuff, just doing that year after year is just not for me. And just bless these people who do that, because it takes a certain kind of personality to be able to do it and do it well. And we're entrusting our kids with them. And you should never entrust your kids with somebody like me. I'm going to teach them how to, be anti-government and do all that kind of stuff. So it's probably not in the best interest of the country, but it's just not in my makeup to be able to do that. So that's something I really wouldn't want to do.
Creatively, what turns you on?
Astronomy. I mean, honestly, there are times when a new image comes along or a new observation of something, not necessarily an image, but a spectrum that we've taken of something, or there have been observations of an asteroid or something, and I'll get excited. Just last week, I wrote for Scientific American. I have to pitch my editor a list of things. Once a month we get together and I'll pitch 4 or 5 things. And we were all ready for me to write one thing. And I emailed him and said, "Oh, we got this new JWST image of a star that's being born. I want to write about this right now." And he's like, "Okay." And I was excited because the image was super cool. I used to study those kind of objects. And I really, really get excited when stuff like that happens. So that gets me going.
In the same vein, what turns you off?
Creatively? Well, certainly the political environment we have now has been really draining. And I've talked to a lot of scientists and a lot of science communicators about this. And it's like, it's really hard to write about how cool this galaxy is when science is being dismantled in our government, or when there's so much anti-science going on. It's hard to see the public health being threatened. and get excited to write about this other stuff. So that like the other day, I was so drained that I was just a zombie all day, and creatively, it had really, really sucked all my energy out. So I'm try to pull myself out of that and get back to writing, get back to talking about this, because everybody needs to, no matter what your political persuasion is, if the news is all bad, it sucks and you hate it, and you can't focus on that 24 hours a day. You cannot be filled with rage and hate 24 hours a day. It will dissolve your body. So you need that distraction. We need to have comedies made. We need to have people writing about beautiful things in the sky or on Earth or whatever, to recharge our mental batteries. And that keeps me going. It really does.
This is my personal favorite question. Mr. Plait, what's your favorite curse word?
Golly. And I say, oh, golly. My favorite curse word. I do say golly a lot.
Jillikers. No.
Yeah, I used to say gee willikers. And then I worked with an astronomer named Jerry Williger. And sometimes I would say gee willikers, and he would say yes. And that was like so brain twisting to me. I am a sweary person, and my public persona is not much of a swearing person, because I used to talk to kids a lot and everything. I've gotten more used to saying things like "holy shit" on Blue Sky, for example, a social media and that kind of thing. And that's a good one. Shitballs is holy shitballs, holy shit snacks is what Pam would say on the show Archer, the TV show Archer. Mm-hmm. And that's one that we say a lot around here.
Now, normally we ask if heaven exists, what would you like to hear God say when you arrive at the pearly gates? But for you, I'm kind of more curious, if aliens landed on Earth today, what would you like them to hear them say when they first arrive?
Oh, gosh, so many answers to that. Well, I would have 84,000 questions, but they'd typically be pretty specific. But like, what's the deal with expansion of the universe? How does that work? What is dark matter? What is dark energy? Is there, can you tell us more about planets around other stars? Is there a ninth planet around the sun?
Answer all the questions we just asked you.
Yeah, exactly. It's like, you guys and they may not know either. I mean, in 100 years, if we develop faster than light travel, are we going to know what dark energy is? That's not a rock solid guarantee. And even if we do, there are going to be more questions. There are always more questions. And that's a fun thing about science. I like to tell people it's a jigsaw puzzle with an infinite number of pieces. You think you've got the picture, and you might have the picture in front of you locally, but you're part of a much larger picture that you aren't even aware of yet. And every time you put in a puzzle piece and it fits, you've got 3 other pieces now that you have to fit in around it. And so science is a puzzle that never ends. You get your answers slowly and surely, but there are always more questions and always more answers out there. And so it's just infinite in scope. And that's one of my favorite things ever.
Well, Dr. Plait, thank you so much.
Wrap this up, why don't you tell everybody where they can find you on social media?
I'm on Blue Sky. Just look up Phil Plait. You'll find me. I have a newsletter called Bad Astronomy. It's the Bad Astronomy newsletter. It's badastronomy.beehive.com, and Beehive is BEEHIIV. But you can just, if you search on Phil Plait, you'll find me. I've been online since there was an online, and so it's easy to find me. I have a large digital footprint.
Well, thank you so much for talking to us today. I would honestly, there's so many more questions that I have.
Yeah, this has been a blast.
If
we're able to, maybe we can have you back sometime.
Well, I've already gone an hour and a half, so you're going to have to do some editing here.